The issue of microplastic pollution can be divided into two parts. One, you have the introduction of new microplastics through wastewater, and two, the inability to model or predict the current fate of microplastics. Eigen Solutions proposes a two-pronged solution, one through prevention and remediation, and a second through modeling.
For engineering solutions, we have two approaches. Approach one will consist of preventing future plastic contamination. This will include deploying earthworms to fragment and depolymerize microplastics in soils and integrating membrane bioreactors and wastewater treatment plants. Approach two will consist of modeling and investigating current plastic contamination. This will include modeling the transport of microplastics in ocean currents and locating agricultural sites where sewage sludge is used and locating microplastics in water via trawling and spectroscopic analysis.
Next, we need to talk about the societal factors for microplastics. First, we need to educate society how microplastics affect wildlife/environment, basically teaching them what they can do to better themselves and their environment around them. And what can we do as society to protect wildlife and environment? As reiterating the first point, we need to inform the public so they are aware of the damages that are caused. Next, we need to stop the domestic runoff. Third, we need to teach society the harms of microplastics on wildlife. And lastly, we need to limit the use of microplastics.
Looking at economic factors, we can see that they play a vital role in solving the microplastic issue. The yearly environmental cost of plastics globally was around $113 billion, with land waste accounting for $362 per ton and the water waste accounting for $626 per ton. This idea of membrane filtration that we've been talking about is an extremely fast-growing market that's projected to reach $7.03 billion by 2024, which is a 49.3% increase from 2019. This growth is due to stakeholders such as the EPA and other private industries. With the cost of the membrane bioreactors being low compared to the environmental cost of $113 billion annually, this encourages stakeholders to invest even more. Without the funding from these stakeholders, the cost of membrane bioreactors would be unaffordable for some communities, and if we want success in microplastic mitigation, we need all the communities to be involved.
Public policy factors are intertwined between both the economics and the effectiveness of the engineering solutions. In approach one, you need to change the operation and infrastructure of wastewater treatment plants, as well as allocate some resources for earthworm remediation. For approach two, it's pretty much you just need to allocate some time and personnel into a modeling studies to support it. So, with the right implementation of engineering solutions and investment into prevention, the reduction of microplastic pollution is definitely achievable. However, it will require the cooperation of engineers, scientists, and policymakers alike.